Hey Geometry, this is 4.3. We are starting to do the main sections of proofs for section 4.3 and 4.4. And this first section just really addresses these two properties, which are SSS and SAS, and we'll kind of go through what each one of those means. And then in 4.4, basically it's the same kind of section again, but we have two different properties. So 4.3 and 4.4 are very, very similar to each other. So in the last section, we said we were trying to talk about two triangles being congruent to each other. So like, let's say I'm taking these two triangles and I'm trying to prove that they are congruent to each other. What we would have to do is we would have to look at all three sides, okay, sides 1, 2, 3, and then we would have to look at all three sets of angles, okay? So show that all three angles match each other, okay? This angle matches this one, this angle matches this one, this angle matches this one, etc. And all three sides match. We would check off all 6 of those things, and then we were able to say, yeah, okay, great. Both of those triangles are congruent to each other, okay? Now we are trying to make life easier for ourselves because we no longer have to do all 6 of these things, okay? What we can say, I'm going to go up here to this, these little properties right here. What we can say, given these two properties, is that if all 3 sides, that's what SSS means, if all 3 sides match each other, they are saying that all of the angles have to follow. So if all 3 sides match each other, they say that there is no choice but for the angles to match each other as well. So we can kind of skip all of these steps because if these things match up, then the angles have to match up. Okay. Now, in addition to that, I'm going to talk about side angle side, which says that if I have 2 triangles for side angle side, here's my 2 triangles, and I have, let's say, this side matching this side and this side matching this side, and the angle that is in between them, then I have a side, an angle, and a side matching a side, an angle, and a side. It does not matter what these other 3 things are, what this angle is, what this angle is, and what this side is. These 3 have to be the same as these ones as long as the side angle side are the same. Okay, so it doesn't matter about the other 3 as long as the side, the angle, and the side are the same. There's no choice but for those 2 triangles to be exactly the same. Okay, so side, side, side versus side angle side. It's eliminating It's basically knocking 6 things down into only 3 things that we have to prove, okay? So this first one here is my proof. Use side, side, side to prove the triangles are congruent. So what we're trying to get is we're trying to get all 3 sides matching each other, okay? So we start with what we're given. For some reason, this diagram did not get printed on your worksheet, or on your note sheet. So take just a second and graph what he looks like. Do your best. I mean, my graph doesn't look great, but do your best you can to draw that guy. If you need to pause this video, you sure can do that. And then we're going to go ahead and start labeling some things, okay? So we have our box ready to go with our statements on the left and our reasons on the right. And we always start a proof with what we are given, and it lists out our given information here. So as we write it down, we're going to mark it on our diagram. This first thing says that GH is congruent to KJ. GH is this side, and it's congruent to KJ. So I'm going to do one little dash to show that those are the same, okay? All right, so, and I'm going to take inventory over here, okay? Inventory is like labeling what all you have, all right? So if I mark off GH and JK that are the same, I already have one side, okay? So one of my sides is checked off for side, side, side. Okay, the next thing that I have is that HL is congruent to JL. So HL is congruent to JL. I'm going to use 2 markings, or two tick marks, to show that so that it doesn't look like all 4 of those segments are the same. And there we go. We have another side for our inventory. So I have 2 sides. I can mark 2 sides off. And then the last piece of given information is that L is the midpoint of GK. So let's take a look at this. This guy is the midpoint of this segment here, okay? All right, that's our given information. That's all that we are given, okay? So after our given information, we have 2 sides that were given to us, and we basically have to tell why the third sides have to be the same, okay? The third sides in my triangle are this side here and this side here, and we have to show why those guys are the same, All right, well, given to us was the fact that L was the midpoint of that line segment. So if L is exactly in the middle, then this guy has to be the same as that guy. If he's exactly in the middle, those two pieces have to be the same. So I'm going to say that GL is congruent to KL, and the reason why that is because of the, I'm going to say midpoint theorem, because a while back we had a theorem that says midpoint. Or you can say, I'm going to do slash or, you can say definition of midpoint. I will take either one of those, okay? By definition of midpoint, if L is the midpoint, then those two things have to be the same, all right? And then that gives me my third side, so I have side, side, side. And then what I was trying to prove was that triangle GHL is congruent to triangle KJL. And I know that those are congruent because of side, 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 and we are done, okay? So these proofs all look exactly the same. I would really suggest you taking inventory on the side to list out what you have and what you need, and then it just makes it really easy. This middle step is all that you have to come up with. And remembering the reasons is probably one of the harder things to do, okay? All right, so let's go. I'm going to go down to skip example 2. We'll pop back up to him for just a second. And we're going to do example 3 first. We're going to skip example 4, but let's hop to example 3 quick, and we'll fill him out. There is one typo on this example. This should say WX and YZ. Otherwise, we're going to end up with some problems here. So WX, YZ. And this isn't in the format that we had above, where it had like given and prove. It's kind of like in paragraph form here, but it kind of means the same thing. So the given pieces of information we have to pull out of the paragraph. Okay, the scaffolding for stage lighting shown appears to be made of congruent triangles. Okay, and they kind of have it highlighted in red what my triangles are going to be. It says if WX is congruent to YZ. That sounds like something that we're going to be given. If WX is congruent to YZ. Okay, I'm going to write that down in my given information. WX, YZ. WX is this segment across the top here. So that guy is congruent to YZ, the bottom. So those two things are exactly the same length. Okay, I'm going to do my inventory over here. And if I have that, I already have a side. Okay, a side is labeled for each one of those two triangles. Okay, the last thing that I have for given information, it tells me that WX is parallel to ZY. So not only are these guys congruent to one another, but they are parallel. So I'm going to do a little arrow that shows that they are parallel. Okay, they're parallel to each other. All right, and really that didn't really give me anything, so I've got to draw some information from that. This proof is just a little bit tougher. Okay, that's the stuff that I was given. All right, and what we're trying to prove is that triangle, this part right here, triangle WXZ is congruent to triangle YZX. Okay, so if you want to go ahead and label that at the bottom here, that has to be our very last step. Your proof is your very last step. Okay, all right, and then what we need, you can kind of see from here that there's going to be 2 steps in the middle that we need, because we need, we already have a side in our inventory, so I can cross off a side, but we need an angle and we need another side for our inventory. Okay, so let's work on that angle real quick. We know that these 2 lines are parallel to each other. Okay, so check out this line that's going through here. Okay, that guy's like a transversal. Okay, and what I notice is, I'm going to do a different color here. How about, let's talk about this angle versus this angle. Those 2 angles are alternate interior angles. And if they're alternate interior angles, those angles have to be exactly the same measurement. Okay, so I'm going to say by alternate interior angles, okay, we know that, I gotta get rid of all my stuff so I can see. It was this angle right here and this angle right here. The top angle is angle WXZ. WXZ is congruent. The bottom angle is YZX. YZX, and those 2 angles are congruent by alternate interior angles. So we have our angle done. Check it off, side angle, side. Now we need one more side. So these two triangles, this guy here and this guy here, we already know that the top side is congruent to the bottom side. So we have two other sides to choose from. We can either pick on this side here and say that it has to be the same as that one, which we don't necessarily know for sure. Or I can say that this middle segment is the same as itself. And we had something kind of like that yesterday. This middle segment is the same as itself. We would say that ZX is going to be congruent to ZX. And that was that duh, right? We had that duh before, which is called the reflexive property. Okay, reflexive property. And that gives me my other side. So I have my side, my angle, and my other side. And then I know that those two triangles are congruent by side, angle, side. Okay, so instead of having to do all three angles, all three sides, we can just pick on the side, the angle, and the other side. We did this side, this angle, this other side. And so the angle was in between the two sides. That's why it's called side, angle, side, not ASS or SSA or something like that. The angle is in between the two sides. So side, angle, side, and that's how we prove that those two triangles are congruent. We don't have to do all 6 pieces now. Okay? All right, so proofs are kind of tricky, but hopefully by taking inventory over here, that's the huge part. You know what you need to get to the end. All right. Last thing, example 2, triangle ABC has vertices 1, 1. Let's plot these guys. 1, 1, 0, 3, and 2, 5. I'll give you a second to do that. A, B, C, this triangle right here. Okay. And we have triangle EFG, or excuse me, EGH. Okay, that's really confusing. They have EGH and then EFG over here. Let's call it EFG. I don't know. That's another typo. I've got typos all over the place in this section, I guess. 1, -1, 2, -5, and 4, -4. So I have this triangle, and we're trying to prove that those guys are congruent to each other. All right. This was EFG. Okay. EFG. I'm trying to prove that those two triangles are congruent to each other. And I'm trying to prove that by side, side, side. So I'm basically saying that all 3 sides are the same length as each other. Okay. So graph both triangles in the same coordinate plane. Check. A is done. B, use your graph to make a conjecture as to whether you think the triangles are congruent. I don't know. They kind of look like they're maybe the same size, but I'm not really sure. So, yes, question mark. I think maybe they're congruent. But in part C, we're actually going to solve and find whether they are congruent or not, all right? And this is not terribly hard, but it's just kind of tedious. I guess it's a long process. What we need to do is we need to look at each one of these sides and find the length of those sides, okay? So think about how you would find the length from like A to B. If I'm given the coordinates A and B, how do I find the length between them? Or how do I find the distance between them? That's that distance formula. Distance formula is the square root x2 minus x1 squared plus y2 minus y1 squared, okay? So what I'm going to do is I'm going to find, and this is the stinky part, the distance from A to B, the distance from B to C, the distance from A to C, okay? And I'm going to see if those 3 distances match what I get when I do the distance from E to F, from F to G, and from E to G. No. E to F, F to G, E to G. Yeah, that's what I want. Okay? So we're going to do each one of these distances. All right. So let's hop back over and let's do our A's first. Okay? So A to B, I have my second X, which is 0, minus my first X. 0 minus 1. Then I have 3 minus 1. So 0 minus 1 is -1 squared, which is 1, plus 3 minus 1 is 2. 2 squared is 4. I'm kind of going through this a little fast. Let's leave it as the square root of 5. Okay, don't convert it to a decimal. Just leave it as the square root of 5. BC, okay, doing the distance there. From B to C, I do my second X minus my first X. So 2 minus 0, 5 minus 3. 2 minus 0 is 2. 2 squared is 4. plus 5 minus 3 is 2. 2 squared is 4. So this is the square root of 8. Okay? And then we do from A to C. All right? Second x is 2. First x is 1. 2 minus 1. Then I do 5 minus 1. So 2 minus 1 squared, that's 1 squared, which is just 1. 5 minus 1 is 4, and 4 squared is 16. So this is the square root of 17. Okay? All right. Now, let's do EF, FG, and EG. Okay? Now, I don't necessarily know that EF corresponds to AB. Okay? So this may not end up as the square root of 5. Because EF might not be the same length as AB. Maybe EF actually corresponds to the square root of 8. So we'll find out here. So E to F. Let's go down here. From E to F, these two right here. Square root. This is not really hard, but it's just a pain in the butt. Second x minus the first x. So 2 minus 1. Negative 5 minus a negative 1. Minus and negative 1. 2 minus 1 is 1. 1 squared is 1. Negative 5 minus a negative 1, or negative 5 plus 1 is, all right, go away. Go away. Oh, right here. I have to hit that button. All right, negative 5 plus 1 is negative 4 squared, which is 16. So this is the square root of 17. So evidently EF corresponds to AC, okay? Then FG, let's do him next. My handwriting is getting really sloppy, I'm sorry. FG, the second x is 4 minus 2. Then I have negative 4 minus a negative 5. So negative 4 plus 5. 4 minus 2 is 2. 2 squared is 4. Negative 4 plus 5 is 1. 1 squared is 1. So this guy is the square root of 5. Okay, so he must go with this first one. So I'm really hoping that EG is the square root of 8. Okay? All right, so E to G. 4 minus 1. And negative 4 minus a negative 1. So 4 minus 1 is 3. 3 squared is 9. 4 plus 1 is 5. 5 squared is 25. You got to be kidding me. This is the square root of 31. Ugh. So even though these two sides matched up with each other, the square root of 31 does not match up with the square root of 8. So really the first thing that I do is I check my answer to make sure that I didn't just screw up on one of those, but I'm pretty sure we did not, because I think this answer is really not supposed to be not congruent. So because all three sides did not match up with each other, I had one side matching, a second side matching, but the third side does not match. So these are not congruent. Okay, we've proved it. We've looked at all three sides. All three sides didn't match up, so they are not congruent to each other. Okay, so that's not really hard. Distance formula like 6 times. Not really hard, but it's just kind of a pain in the butt. Okay, so 2 proofs and, you know, a bunch of distance formulas later. Homework, you guys have 4-3 practice and skills practice. I lumped off like number 1 and number 2, or no, excuse me, 1 and 3 on practice. So you only have to do one of those distance formula ugly things on number 2, or on this side. And then I'm pretty sure I did the same thing on the second page. So you can lump off 1 and 3 on skills practice as well. So you only have to do 6 sets of distance formulas on the backside instead of 12. I want to go through like number 4, 5, and 6 on the first page, because they're asking for whether or not you can prove that the triangles are congruent. And they specifically want, can you use side, side, side? Can you use side, angle, side? Okay. So for number 4, I have that this side is matching this side, and that's all that I know. That's all that's marked anyway. One other thing that I can add to that is that this angle matches this one, because those are vertical angles. So I really have a side and I have an angle, okay? But that's all that I can draw from that figure. So I have a side and an angle. If I was able to find another side, great, but I cannot. So this one is going to be not congruent. Even though they look like they're congruent, given the information that we have, we're not able to determine that those two triangles are exactly the same measure. Okay, so go through each one of these, 5 and 6, see if they're a yes or a no. If they're a yes, label them with side, 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 or side, angle, side. Okay, and I think you have like 2 proofs on here. No, 1 proof. 1 proof is all. Just number 4. Okay, and he's going to be kind of similar to the one that we did or one of the 2 that we did, I guess. So that is what I have for section 4.3. 4.4 is what we'll go through tomorrow, and that should be kind of similar to this section.